Hello guys, so let's start today's little challenge. You have planned some time traveling 1 year in advance. The days of the year in which you will travel are given as an integer every day. Each integer is from 1 to 365. Train tickets are sold in three different ways. A 1 day pass is sold for cost of $0, 7 day for cost of one, and a 30-day pass for cost of $2. The pass allows many days of consecutive travel. For example, if we get a 7 day pass on day 2, then we can travel in 7 days. That is 2, 3, 4, 5, 6, 7, and 8. We have to return the minimum number of dollars to travel every day in the given list of days. So, solve this problem now. This is our first example given in the question. Days every have this and cost area is this. At the zeroth index of cost, we have the price of traveling for 1 day, and at the first index, we have the price for traveling 7 days, and on the second index, we have the price for traveling for 30 days. Also, in the constraint, it is given that Q days is in increasing order and so all the elements in the day array are in increasing order and are also used. So at I equals to 0, that is day 1, we take a 7 day pass, so it will cover days from 1 to 7, both 1 and 7 inclusive. We will reach I equals to 4 elements, that is 8, and that would cost us 7. So let's solve the root cause approach. This is the first day from where we are starting. To reach second day, we would require a 1 day pass. To reach 8th day, we would require a 7 day pass. And to reach 31st day, we would require a 13 day. These three options we have at the first day of our days array. And for every element in the days array, we have all these three options. So we would explore each of them as it is. We would add 2 here as it is the cost for 1 day. 7 is it is the cost for 7 day pass, and 15 as it is the cost of 15 days. Now from second to third day, we would require any cost, as I will store all of these in a hash set because they are unique and using order. If we reach any days which are between these, we won't require any cost to reach until then. That's what I have written over here. So I would just skip it. Same from this. Now, from third to fourth, it won't require any cost. But from fourth to fifth, I would require cost of $1 to go and this present in this. Same goes for this is 1 day, this is 7 day pass, and this is 30. This would be the days after taking transfer code. As this is a recursion, We would define a base case. Base case would be the current day is greater than max case, which would be the last index, 20. Then we would just return 0. If not, we would find the minimum out of all these three parts, minimum, and return that. Its minimum is the optimized code. First, we would go with the first expression. First, I would create a set of holidays, then write the recursive function, passing in current day, and I would call this function at the end, days of 0. You write this function. I would I would write this function if the current day is greater than days of -1. This is our base case. I would return 0. Now, if my current day is not in the set event, means skipping over this day won't require me any cost. So I could just call that the again required day plus 1. Now that is not the case. If current day is present in dy, I would exhaust each and every choice. This is for the 1 day pass, for the 7 day pass, which would be cost from 1. Okay, so this is costs plus recurrent current day plus 7 equal 30 days. I will require this much. Now I will return minimum out of all these three. So I will just write it like this: 7 day, comma 30 day. Now let's run this code and see whether it's working or not. Okay, because it's not there. Now it's running. It will not pass all the test case. We will get a runtime for the code. Time complexity will be 3 raised to power 360. So it would give a DL. We passed 26 test cases. Let's try to optimize this code using TP. And just erase all of this. Last day equals to day minus 1 plus 30. This would be the last day we can reach. Suppose the maximum was 20 in this example. So adding 1, 7 or 30. Either of the three would pass our base case condition of current day is greater than the days present here, max of days. So that is why I'm adding the 30 because that is the last thing we could reach using the recursion calls. Create a DP element. Last day plus 1. Now for present day in range days of minus 1. Reverse. The base case was that current is greater than days of minus 1. DP of current day. See, that's what I'm going to do. Now, if current day is not P by DP of current day plus to DP of current day plus 1. No costing will be available. Directly we will go to the previous index. Now, in place of this recursion call, I will just write P of current day plus 1. Same goes here. P of current day plus 7. Again, same thing. I would store this in DP of current day. DP of current day would be minimum this. I would return DP of days of 0. This would be our answer. Let's run the code and see. Okay. Okay, we forgot to add a continuous statement here. This part of the code would not get executed, not in debye. So we have to write this continuous statement. Now let's run the code. Okay, it's passing all the base cases. So let's see whether all the test cases are passing. Yep, it's passing all the test cases. Let's meet tomorrow. Bye bye.